Timecode is the professional way to synchronize footage when shooting with multiple cameras and external audio recorders. It is also a mess of backwards compatible hacks, seemingly odd limitations, strange configuration options, and all the rest of the weird things that are needed to make things work in a backwards compatible industry standard way. In this video, we are going to do a complete deep dive on the timecode system found on Canon's Cinema EOS cameras, from what the options are in the menus and how to configure them to a practical look at some configurations that might be useful to you for setting up your gear in the field. Now, with that said, the demos and examples in this video were shot using Canon's EOS R5C running firmware 1.1.2.1. However, with few exceptions, most notably the physical connectors on the camera, the R5C's capabilities are exactly the same as the rest of the Cinema EOS camera line. So if you are shooting on a C50, a C70, C80, or C400, your camera will function in essentially the same way as what I am showing in this video. Now, there are a myriad of reasons why you might want to be able to address individual video frames specifically. This includes things like synchronizing between multiple cameras or audio and video from separate recorders, or even locating frames where to place cuts when editing. Now, the solution to this is some kind of index for which for most of us is going to be timecode. Now, the Society of Motion Picture and Television Engineers, or the SMPTE, has standardized the format for video timecodes in the ST12 standards. There's 3 of them. However, they are not the only body that has produced timecode standards, and you can find essentially the same or virtually identical standards published by other bodies like the ITU, the EBU, and the IEC. Now, I have done an extensive video on the details of SMPTE timecode, so if you are interested in a more detailed look at what's going on under the hood and what the standards are, I will link that video in all of the usual places. That said, for the purposes of this video, there are effectively 2 timecodes that we need to be aware of. First is the QuickTime timecode metadata standards. Now, this is more or less what's written to the timecode stream in our video files when we record something on our camera. The other is the Society of Motion Picture and Television Engineers Linear Timecode, or LTC, standard, which is what is used to send timecode information between devices. This is what we feed our cameras either through a dedicated timecode port or into the audio input so that we can process and sync things in post. Now, Canon's cinema cameras support both internal timecode generation and external timecode synchronization, as well as embedding a timecode in the recorded video files and exporting their internally generated timecode signal to other devices to be used for synchronization. Now, in addition to generating and receiving timecode information, Canon's Cinema EOS OS gives us full control over the SMPTE timecode's binary groups, which is also known by most people, or to most people, as the user bits. These user bits allow the timecode to store arbitrary data, time, and date and time zone information depending on how they're configured. Now, on these cameras, a dedicated timecode port allows them to interface with other devices. On the R5C and C50, the timecode port is a DIN 1.0/2.3 connector. This is a locking connector, and of special note, due to the depth of the port, the R5C requires a long connector to allow the cable to be released. Now, the larger cameras like the C80 and C400 use standard BNC connectors instead. The timecode information is added directly to your video files as a dedicated timecode stream in, as best as I can tell, the QuickTime timecode format. Now, in addition to supporting the input and output of SMPTE LTC timecode data, the camera also supports exporting the timecode over the HDMI port or signal as well. This can then be used by external HDMI displays and recorders as their timecode source, and in some cases even audio recorders. Additionally, the HDMI timecode output does not interfere with the timecode port or the other parts of the timecode system. The camera can sync with an externally supplied LTE or LTC timecode signal using the timecode port, and then output the synchronized timecode over the HDMI port to downstream devices. Now finally, there's the high frame rate recording situation. The SMPTE does have a standard for high frame rate timecodes, but unfortunately it is not supported in the LTC transport bitstream. As a result, using the external timecode source is not possible when shooting in slow and fast motion mode. And in fact, switching the camera into slow and fast motion mode will cause the camera's timecode system to switch to record run, which also disables the external timecode input. Now, Canon notes, at least on the R5C, that when pre-recording is active and an external timecode source is used, there may be a discontinuity in the timecode of the pre-recorded clip. I take them at their word on this because I haven't actually tested to see what this happens or when and how this is going to affect things, especially using that recording in post. Now, before I get to the timecode settings, let's take a quick look at how the camera displays the timecode information and what that displayed information tells you about the camera's configuration. Now, the current timecode is displayed in the upper right corner of the on-screen display. The timecode can also be hidden if so desired, as it's part of the Level 2 display elements. Canon separates their informational elements or iconography into two groups, Level 1 and Level 2. Level 1 elements are the less essential ones, and they're only showed when the camera is set to the Display Level 1 overlay. That's the one with all of the icons. Level 2 elements are more important, all things considered, and are displayed on both the Display Level 1 and 2 overlays. The Level 2 overlay is obviously this one with the fewer distracting icons. Now, the timecode is displayed in the usual hours, minutes, seconds, frames format, with the separator being a colon between almost or most of the numbers. However, the last separator, that's the one between the seconds and frames places, is used to indicate whether the camera is using non-drop frame mode, in which case it will be a colon, or if it is in drop frame mode, in which case it will be a period. Finally, the timecode is suffixed with a letter that indicates the configuration of the timecode system. An E indicates the camera is synced to and running on an external timecode source that's plugged into the timecode port. An F indicates the camera is in free run mode and that the timecode mode is set to preset. A P indicates the timecode will only advance while recording, so record run mode, and that the timecode mode is also set to preset. And finally, an R indicates that the timecode mode is set to regen, with all of the considerations that come with it, which we'll talk about in a minute. Now, finally, in playback mode, no letter is displayed, and the camera does not generate or output a timecode for the clip while it's being played back. Now, in addition to the rear screen, the timecode can also be seen on the R5C's top LCD screen when set to the second screen or display page. The timecode settings are found in the System Setup menu. On the R5C, they take up the entirety of page 3 of that section, though the HDMI timecode settings are actually found on the last page of the Recording Media Setup menu instead. The first setting is the timecode mode, and this setting has two options, preset and regen. Preset, which is the default, starts the timecode from the value you set through the set timecode setting and continues to increment it as the timecode passes. In preset mode, as the timecode updates over time, as I said, the camera retains the updated timecode through power cycles and battery changes and so on and so forth. The other option, regen mode. In that mode, the camera reads the timecode from the last file that it finds on your card and sets itself to the next frame after that file's timecode ends. Now, if you are not working with an external timecode source or don't really care about timecode in general, you might want to actually consider using regen. In this mode, the camera will only apply timecode information to your videos while they're recording, or will only increment the timecode while the videos are recording, and will make the timecodes continuous from clip to clip as time goes on. Now, if you are using the timecode system as a secondary time of day reference, or you are going to use an external timecode source, you want to use preset. In fact, you must use preset for external sync due to the free run requirement. The next setting is timecode run. This controls when the timecode is incrementing or running, and the two options here are rec run and free run. Rec run, or record run, the default, increments the timecode only when the camera is recording a video clip. At the end of the clip, the timecode stops advancing and will not resume until you start recording again. Rec run is a good choice if you are not using the timecode for production synchronization or aren't using the timecode at all, or actually if you're using the R5C or your cinema camera as a timecode generator, that can be useful there too. Since it only increments the timecode when the camera is recording, that can be less distracting in general while you're setting things up, and it keeps the clip's timecodes continuous. Conversely, in free run mode, the timecode is continuously incremented whether the camera is recording or not. Free run is what most people using timecode as a production tool are going to want to use. Moreover, if you are synchronized to or trying to synchronize to an external timecode source, the camera absolutely must be in free run for that to work. Timecode DF/NDF, or drop frame / non-drop frame, controls whether the camera's internal timecode generation uses drop frame compensation or not. This compensation corrects for the time shift that occurs due to fractionally slower or fractional NTSC frame rates, causing the timecode to drift from wall clock time. Now, this setting is only available when the system frequency is set to 59.94 Hz and the recording frame rate is set to either 29.97 or 59.94 frames per second. In non-drop frame mode, every frame is indexed continuously. This results in the timecode's time drifting from wall clock time by plus 3.6 seconds per hour. Now, in situations where it's necessary for the timecode and wall clock to advance at a comparable rate, you will need to enable drop frame compensation. When enabled, drop frame compensation omits the first 2 frame indexes from the first second of every minute except for the minutes that are evenly divisible by 10. So 0, 10, 20, 30, 40, 50, and 50. Now, that said, if you are using the timecode to count frames, for instance, to calculate the elapsed time between events, you probably don't want some seconds to have 28 frames and some to have 30. In those cases, you'll want to use non-drop frame mode and adjust your timing calculations by using the 1/1.001 timecode or frame rate correction instead. Set time code is less of a setting and more of a submenu, and this is where you go to set the setting or starting time code used in the preset run mode. Now, entering this brings you to a screen with fields for the hours, minutes, seconds, and frames that you want your time code to be set to, along with 3 buttons along the bottom: change, reset, and cancel. Selecting change after setting a time code will update the camera's current time code to the set value. Selecting reset will reset the camera's time code to 0 hours, 0 minutes, 0 seconds, and 0 frames automatically and exit the page. Finally, selecting cancel will take you out of the menu page without changing the time code. Now, alternatively, you can press the physical cancel button to do the same thing instead. Now, unfortunately, the one thing that's missing is the ability to set the time code to match the current current camera's clock time. Now, this isn't accurate enough to be frame accurate for synchronization purposes, but if your camera's clocks are close enough, you can get close, at least close enough that you can fix the offset of 20 or 30 frames easily in post if that's how you want to go. Canon's cameras use a 2-wire timecode connection. The R5C and C50, as I said, use a DIN 1.0/2.3 connector, and the C70, 80, and 400 use standard BNC connectors. As a result, these are not bi-directional ports, and you have to configure the port as either an input or output before you can use it. This is what the TC in/out setting does. By default, this is set to in, which allows the camera to accept an LTC timecode signal on the port and process it. However, to receive and use the actual external timecode, in addition to having the TC in/out setting set to in, you must also have the timecode mode set to preset and the timecode run setting set to free run. Alternatively, the R5C and really all of the other cinema cameras can act as a timecode source or master. This is enabled when the TC in/out setting is set to out. In this case, the camera generates an SMPTE compliant LTC data stream based on its own internal timecode and puts it out on the port. The user bit recording mode setting controls how the camera adds, or what values, I should say, the camera uses for the so-called user bits that are part of the timecode signal. Though this is something of an advanced feature that isn't going to be relevant to most users, we're going to talk briefly about it anyway. The user bits are 4 bytes or 32 bits of perfectly user customizable data that is embedded in every SMPTE timecode packet. They can be used to store extra data such as date and time zone, arbitrary user-defined data like whatever you can put in 32 bits, for example, a scene ID, a take ID, or a camera information. When the setting here is set to external, the camera will copy the user bits that it recovers from an external timecode signal that is applied to the timecode port, and it will write them into the video's metadata. When this is set to internal, the camera ignores the external timecode's user bits and uses the internal user bits that are set using the user bit type setting. Now, this can be useful if you are using the user bits to encode, for example, a camera ID or other camera-specific information, as that will be different from camera to camera compared to what can be sent out on the timecode to all cameras. The user bit type setting controls how the camera sets the so-called user bits. There are 3 options here: setting, time, and date. Like the user bit recording mode setting, this is an advanced timecode setting that most users are not going to need to deal with. That said, use the setting to set your own arbitrary values. These are represented by 4 pairs or octets of hexadecimal numbers. The time setting is something of a mystery to me. Well, it's not entirely a mystery to me. It encodes the current clock time in the user bits. However, there is no standard encoding for this as far as I can tell, and so the utility of this may vary from position to position. The final option is date, and like the time setting, Canon doesn't give specifics on how this is encoded in the user bits. Now, the final timecode related setting is not found on the timecode settings page at all. It is in fact found on the last page of the recording media setup menu, and this is the HDMI time code. Now, this has only 2 options, on and off, and they're pretty self-explanatory. At least I think they are. The HDMI timecode setting controls whether the camera outputs timecode information on the HDMI port. When enabled, the HDMI timecode matches all of your other timecode settings, including when your camera is synced to an external timecode source. So, for example, if you are recording to an Atomos recorder, instead of, say, feeding the LTC timecode into that recorder as a waveform, as many people will sort of recommend, what you can actually do is feed the R5C with the LTC timecode through its timecode port, get it synchronized, and then feed the HDMI timecode out of the HDMI port with the setting turned on to your Atomos recorder. This way, your recorder will actually record the time codes as native video or native time information in your video, as opposed to an audio track that you have to process later. This can also be done or work with sound devices MixPre 2, the 3, and the 6 versions of our audio recorders to provide them with timecode information. Now, to wrap this up, I want to look at a couple of examples of various configurations. Now, the first example or setup I want to cover is a bit of a special case, but it can be handy if you are shooting two-system audio with a single camera and a generic audio recorder, or if you're just trying to sync two cameras, actually. We'll set the camera up as a timecode master. So we'll set the TC in out to out, and that's really all that has to be done here. Timecode mode and timecode run can be set at your discretion to get the effect you're looking for. Almost anything that does timecode will be able to deal with this kind of setup. Or alternatively, anything that's recording timecode as audio, I should say, can deal with this kind of setup. Now, on your recorder, the only thing you need to configure is the input to essentially line level, since the R5C's timecode output is compliant with the SMPTE's LTC, or linear timecode levels, and produces a signal that's approximately 1.36 volts peak to peak, or about 620 millivolts RMS. Now, with that said, as long as you're using a digital recorder and its inputs can tolerate the voltage, which most everything can, in my experience, clipping is not actually a concern with LTC data. As you can see here, I am running this signal into a second Canon R5, and in this case, the R5 does not have a line level mode. However, as I pointed out, unlike actual audio files, clipping is not a problem with the LTC timecode track, as this clip demonstrates. Now, of course, this approach does require processing the recorded timecode data in post and adjusting those files to be able to use it, but at least you have it. Now, with that said, a better solution is if your recorder or other camera supports timecode input directly or natively, and in that case is to use the timecode to directly set the camera or recorder's timecode system and record that. In this case, you will use the same setup as you would for recording the LTC signal as audio, but plug the cable, obviously, into the TC-in connector. Now, you will also need to change your recorder's timecode settings to accept sync, if that's a requirement, on its timecode import, because not everything does that by default. Now, I want to point out one better solution for Zoom F6 and F8 users, although this also would apply to MixPre 2, MixPre 3 2 and MixPre 3 or MixPre 6 2 recorders, but using HDMI. And that is a take that works really well for solo shooters recording two-system audio with timecode synchronization, or that want to use timecode synchronization. The F6 and F8 have an external auto record timecode mode. When this is enabled, the recorder will automatically start recording when it receives a timecode signal, and it will stop when that timecode signal stops. So in this configuration, we're going to set the TC in out on our camera to out, so the camera outputs timecode, obviously. And then we're going to change the timecode run to record run, or set the timecode mode to regen, so that basically both does the same thing. Ultimately, though, we want the camera to only generate or output a timecode signal when it is actually recording. Now, when you start recording on your camera, the recorder will also start recording automatically. And when you end the recording on your camera, your recorder will also stop. Now, that said, the timing for starting and recording is not guaranteed to be absolutely perfect. You will still need to obviously align the timecode files in post by timecode to the files by timecode in post, and you will want to make sure, as usual, that you have some pre and post roll, that you're not just starting the moment that something happens or you want somebody to start saying something, just to ensure that you can make everything or get everything synchronized. Now, the final setup I want to cover for the R5 or the Cinema EOS cameras is using an external timecode source to drive the camera's timecode system. Now, again, for this to work, you will need to set the timecode in and out to in so that the camera can accept the timecode on its timecode port. Next, the timecode mode has to be set to preset, and the timecode run must be set to free run. Now, you can confirm your camera is set up correctly for all of this before you hook up an external source without going through the menus, simply by noting that the displayed timecode is constantly counting up and ends with an F. Now, once connected to an external timecode source, the suffix will change from an F to an E, indicating that the camera is now using the external timecode signal. Now, one nice feature that Canon cameras actually have is that they will automatically jam sync their internal timecode system or counter to an external signal when you apply it. This means that you can actually just disconnect your external timecode box and the camera will continue to maintain its timecode in sync with what it was set to, at least again within the limits of the camera's timing capabilities, which, if they're anything like everything else that does timecode, is probably a frame per day or so of accuracy or error. Now, while this jam sync setup can drift over time, as I just said, in the short term, over a few hours, or over the course of even a day, most cameras should be able to remain frame accurate or within a frame of any of your other devices without continuous external synchronization. So, with all of that said, that's how Canon has implemented the timecode system in their Cinema EOS cameras. That said, I hope you found this useful, or at least interesting. If you did, let me know by hitting that like button. Also, if this kind of thing seems like it might be your kind of thing, please consider subscribing if you haven't already. Finally, if you'd like to help and support this channel, you can help us for free by liking this video, sharing it with your friends, and leaving a comment with your experiences. Likewise, you can support us by hitting that thanks button or buying yourself something you've always wanted from one of the affiliate links in the description below. And as always, thanks for watching, and I'll see you next time.